Reactivity of benzene, toluene, phenol, and aniline. Which one is more reactive and why? This is what we are going to learn today. So let's get started. Reactivity of benzene, toluene, phenol, and aniline. Let us start from benzene. This is benzene. In which, what is this? What does this ring mean? This ring means circling of pi electrons. Circling of pi electrons. Because of these pi electrons, benzene undergoes electrophilic substitution reaction. Benzene undergoes electrophilic substitution reaction. Here, this electrophile attacks any of the 6 carbon atoms, and as a result, benzene changes to this ion. Electrophile, here hydrogen, a kind of ion which is called sigma complex. Then, because of this positive charge inside the benzene ring, covalently bonded electrons of carbon and hydrogen move here to vanish this positive charge present in the benzene ring, and in this way this hydrogen gets free as electrophile proton, and finally this is obtained electrophilic substitution product. Hydrogen gets free as electrophile. Here, this is electrophilic substitution product. This reaction occurs due to the presence of these pi electrons. Actually, the reactivity of benzene ring depends on the electron density. Electrophilic substitution reaction of benzene ring depends on the electron density present here. When density of electrons in the benzene ring is higher, then it will be more reactive. If it is lower, then it will be less reactive to the electrophile. So, electron density is only the parameter of the reactivity of benzene ring. Now, let us see about these compounds. Toluene. Here, this is methyl group, which is also known as methyl benzene. Then, phenol. Oxygen contains 2 lone pairs of electrons. Then, aniline, which is also known as aminobenzene, in which nitrogen contains 1 pair of electrons. Here, methyl group, hydroxyl group, and amino group. All these groups are electron donating groups to the benzene ring. That is, methyl group is benzene ring activating group, hydroxyl group is benzene ring activating group, and amino group is benzene ring activating group. But Which one is more reactive? Which group activates benzene ring to the maximum? That will be the more reactive compound here. Here, methyl group. We know that methyl group is electron donating group, and there is a characteristic of benzene ring due to the circling of these pi electron. Due to the circling of these pi electrons, benzene ring achieves electron withdrawing nature. Phenyl group achieves electron withdrawing nature. This is number one. Number two, phenyl group is electron donating group to the benzene ring through hyperconjugation. It has been discussed in detail in the Toluene section. That is, methyl group donates electron to the benzene ring through hyperconjugation. Again, electronegativity of carbon is 2.5, which is comparatively less than oxygen and then nitrogen. Now, let us see about phenol. We know phenyl group is electron withdrawing group. Again, hydroxyl group contains two lone pairs of electrons, two free pairs of electrons. So, phenyl group withdraws lone pair of electrons a bit easily. In this way, hydroxyl group activates benzene ring. That is, due to the presence of hydroxyl group in the benzene ring, electron density increases. Electron density increases in the benzene ring due to the presence of hydroxyl group. Due to the presence of methyl group, here as well, electron density increases. But here, electronegativity of oxygen is 2.5, which is less than oxygen. Here, electronegativity of oxygen is 3.5. Oxygen's electronegativity is higher than carbon. Electronegativity, the power of pulling electrons, covalently bonded electrons towards itself. The power of pulling covalently bonded electrons towards itself is electronegativity. Here, oxygen's electronegativity is higher, but oxygen contains two free pair of electrons. That is why hydroxyl group increases electron density in the benzene ring a bit higher compared to methyl group, because in methyl group no lone pair of electrons. No lone pair of electrons. So, lone pair of electrons has greater effect in increasing electron density in the benzene ring. So, we can say that phenol is more reactive than toluene. Now, let us see about aniline. We know that phenyl group is electron pulling group. This is number one. Number two, nitrogen has one free pair of electrons. Number three, its electronegativity is lower than oxygen. That is, nitrogen pulls electron from the benzene ring, which is less than oxygen. So we can say that amino group has greater effect to increase electron density in benzene ring compared to hydroxyl group and compared to methyl group. That is, in aniline, nitrogen contains free pair of electrons and its electronegativity is lower than oxygen. So in aniline, amino group increases electron density to the most compared to phenol and toluene. That is considering electronegativity, free pair of electrons, and here no lone pair of electrons. Considering these points, we can say that aniline is more reactive because amino group here increases electron density in the benzene ring maximum, and in case of phenol, hydroxyl group increases electron density in the benzene ring which is medium. But in case of toluene, phenyl group increases electron density which is less than hydroxyl group and then amino group of aniline. So we can say that reactivity of these compounds. Firstly, aniline, which is more reactive towards electrophile. Then phenol, and then toluene, and finally benzene. Reactivity of these compounds. Here, amino group increases electron density in the benzene ring by positive mesomeric effect. Mesomeric effect related to lone pair of electrons. In phenol, hydroxyl group increases electron density in the benzene ring by positive mesomeric effect, and in toluene, phenyl group increases electron density in the benzene ring by hyperconjugation, and we can say that by positive inductive effect. Positive inductive effect. Inductive effect is related to sigma bond. Inductive effect is related to sigma bond. Mesomeric effect is related to lone pair of electrons. So finally, we can say that aniline is more reactive and benzene is less reactive among these compounds. Thank you for watching.